Hello students, welcome to Unit 6 Notes, Section 8.4. I'll do the warm-up with you. So for each triangle, find A, the length of the leg opposite angle B, and B, the length of the leg adjacent to angle B. Okay, so here's angle B. So we're going to say the opposite side is going to be opposite to angle B is 9, and adjacent to angle B is 12, because here the hypotenuse is always 15. So here's our opposite and our adjacent. All right, angle B here. Here we have the hypotenuse, and there's angle B, and that's your opposite side, and that's your adjacent side. So, oops. I'm just going to copy this over. So that's your hypotenuse. Therefore, remember the hypotenuse is always opposite the right angle, making this one the opposite side, which is 7. And the adjacent side is 2 square roots of 78. In our last one, we have the opposite angle B. Well, here we have the hypotenuse always, and then we have opposite is over here, which is 10, and the adjacent is 3 square roots of 29. So 3 square roots of 29, and here is 10. All right, so that we found both A and B for each one of these. And that was A, that was B, A and B, and A and B. All right, today we are focusing on sine and cosine. So we already did tangent, but now we are working with sine and cosine identities. So you use the sine and cosine to determine the side lengths in triangles. Using sine and cosine in triangles, the sine is equal to, of an angle, is equal to the leg opposite over the leg that's hypotenuse, which in every case, the hypotenuse is always the greatest side in a right triangle. It's opposite the right angle. And then cosine is the adjacent over the hypotenuse. So here we have sine of A is equal to opposite over hypotenuse, or I can say sine of A, sine of angle A equals O over H, and cosine of A is equal to A over H. So what that simplifies us to is sine is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse. And in my last video, we learned about the tangent, which is opposite over adjacent. This has a really cool final acronym that we can use, and the acronym is SOHCAHTOA. And this is what students all over the United States are probably learning, if they haven't already, in geometry SOHCAHTOA, where the sine function is equal to the opposite over hypotenuse, the cosine function is equal to the adjacent over the hypotenuse, and the tangent function of my angle is equal to the opposite over the adjacent. So we have a abbreviation that we can use as we travel, something very quick that we can set up. And from this statement here, we can set this one up, or this one up, and get a very quick get a very quick calculation going. All right, and with that, here's what's really cool about sine and cosine. So one way to describe the relationship of sine and cosine is to say that they are actually a difference of 90 degrees. So the sine of 0 is actually equivalent to the cosine of 90 minus 0, which is 90. And the sine of 1 degree is actually equivalent to the cosine of 89 degrees, because 90 minus 1 is 89, and so on. So sine of 2 is equal to cosine of 88. Sine of 10 is equal to cosine of 90 minus 10, which is 80. And we can check this in our calculator. We can actually check this work in our calculator here. So we have the, we're going to want to make sure we're in degree mode. Notice I changed this to degree mode. And we can do the sine of 1 degree, and we can do the cosine of 89 degrees, and we see that they're equivalent. We can also do the sine of 10, as long as they add up to 90, right? So cosine of 80, we actually have is equivalent. Okay, how about sine of 90 degrees, and cosine of 0, because 90 minus 90 is 0. Boom, there we go. We can see that they're equivalent. So that is part of our identity. So that's also one thing that we can take account for. And the reason why here is because if I'm looking for the sine of angle A, it's equivalent to the cosine of angle B, because the sine is going to be opposite over hypotenuse, where cosine will be adjacent over hypotenuse. They're still both BC over BA in both of those cases. That's what's really cool about those. So let's do a couple problems. Let's first start by writing the sine and cosine ratios. So use the triangle to write each ratio. So sine and cosine. So let's write the sine of t. The sine of t, here we're going to have the opposite. Well, this is always the hypotenuse. So I have the opposite over the hypotenuse. And so we're going to have 8 over 17. So sine of t is equal to 8 over 17. Let's just put this in parentheses. These are angle measures, so I like to put them in parentheses. Cosine of t is going to be equal to again, this is the hypotenuse always. It's going to be equal to the adjacent side over the hypotenuse. So it will be equal to 15 over 7. And now sine of g is going to be equal to the opposite over hypotenuse, which is 15 over 17. And then the cosine of g, I mixed these up, hold on. Sine of t, cosine of t, oops, 17. The sine of g, okay, no, I'm good. And then the cosine of g is the adjacent over the hypotenuse. So that's going to be the adjacent side, which is 8. So 8 over 17. And so it says write the sine and cosine ratios for angle x and angle y. Well, here's what's really cool. Check this out. We have 8 over 17. Take a look at this one and this one. So what we can say is actually we're able to say that sine of angle t is equivalent to cosine of angle g, right? Because they're both 8 over 17. And then these two, we can say the sine of angle g is equal to the cosine of angle t. Again, the sine of this angle is equal to the cosine of this angle, and the cosine of this angle is equal to the sine of this angle. So they flip-flop because they're the same values. Maybe I should do this in a little bit different way. I'll just move this down. Okay, write the sine and cosine ratios for x and y. And what we got to be careful here is we just want to make sure that when we write sine and cosine, that we're going to take into account that we need to simplify it. So sine of angle x is going to be equal to the, let's just write them and then we'll simplify them later. So it's 64 over 80 because it's adjacent, it's opposite over hypotenuse. Okay, and the cosine of angle x is going to be equal to the adjacent over the hypotenuse. So that's going to be 48 over 80. And then we're going to have angle y. So I need to erase these because these will change. The hypotenuse will always stay the same. So y, that's my opposite and my hypotenuse. So sine of angle y, that should be a capital Y, equals 48 over 80. And then the last one is the cosine of angle y, which is going to be the adjacent side over the hypotenuse, so 64 over 80. What I do need to do is I need to simplify them. So I would really like to see how many times, what I can simplify this to. So I'm thinking this ends up becoming 4/5. Okay, it becomes what? 64 divided by 8 is 8. 80 divided by 8 is 10, which ends up giving me 4/5. And then cosine, let's see, cosine ends up being 6 times 8 is 48. So I divide both by 8, I get 10 and 6, and I get what, 3/5? And this one is going to be 3/5 because I already did the math for it, and I already did the math for the last one, which is 4/5. So, yeah, 64 divided by 80. Let's have this 64 divided by 80. Whoops, let's clear some of these out. Is 4/5, and 48 divided by 80 is 0.6 or 3/6. 3/5, I mean. Yep. Click this little button here, right near the left of it, and it will actually put it back into fractional form for you as a simplified version, which is really cool. Desmos has quite a bit going on for us. So, I'll leave the calculator up for right now. Switch these. Let's see, can I switch them? There we go. All right. So, write the sine and cosine ratios. So I'm going to write them a little bit nicer. We have the sine of angle x, and then we'll have, I'll just rewrite them in a totally different color. Sine of angle x, and then cosine of angle x, and then sine of angle y, and cosine of angle y. You know what, I don't need to rewrite them. They're all right over there. That's fine. I'll just circle the final answer. 4/5, 3/5, 3/5, and 4/5. And then it says, when does sine of x equal cosine of y? When do they equal? When does sine of x equal cosine of y? Explain. Sine of x equals cosine of y always. Okay, it will always equal it. The answer is always. Explain. They are cofunctions. And take a look at it. Look at sine And let's take a look at cosine. Look at this word co. What that means, whoops, I meant that one. What it means is complementary. And so the co part of it means that if the sine of 1 degree will have to equal the cosine, it's complementary of sine, to 89 degrees. That's just how they work out. Tangent, the tangent, I didn't teach you this. You don't need to know it right now. We're not going to use cotangent, but the same thing happens for tangent. So the tangent of 1 equals the cotangent, which we're not using cotangent, but it would be the cotangent of 89, and so on. Okay? All right. Use inverse of sine and cosine. So now we're going to use the inverse of it. I didn't even have one where I had to solve for a side length. That will come up shortly, I'm sure. Yep, we'll have to find some side lengths here. Yeah, we'll go through this one pretty quickly. Okay, so let's find the inverse of sine and cosine. And the inverse of sine and cosine, so there's two methods here. For angle L, okay, for angle L, here's one method. If I want to know the degree measure of angle L, what I could do is the sine, which is going to be opposite over hypotenuse. Okay, and so the sine of angle L is equal to opposite over hypotenuse. So the sine of angle L equals 3.2 over 4. So sine inverse of 3.2 over 4 is equal to the measure of angle L. So I'm going to do sine inverse. I'm going to type in 3.2 over 4. And I get about, so I get the measure of angle L, approximately equals 53.130 degrees. And it wants it to the nearest degree. So I'm just going to say the measure of angle L approximately equals 53 degrees. Okay, that's method 1. Method 2 is using cosine. So let me do cosine instead. I'll do the adjacent over the hypotenuse, which is 2.4. So the cosine of angle L is equal to the adjacent over the hypotenuse. So the cosine of angle L equals 2.4 over 4. So cosine inverse of angle L is equal to, the cosine inverse of 2.4 over 4 is equal to the measure of angle L. We're just flipping them. Remember, you flip them and you make them the inverse. You just flip the inputs and outputs. And so now I'm going to say measure of angle L approximately equals, and I'm going to go to my function, and I'm going to type in cosine inverse of 2.4 over 4, and I get 53.130, and which is exactly, measure of angle L is approximately the exact same thing. It's weird to use approximate and exact in the same sentence, but as before. So what we have is 3.2 over 4 for sine inverse, but for cosine inverse we have 2.4 over 4, and no matter what, they end up being 53 degrees approximately. All right. right, so that you can do either method for this one if they give you enough information. In this case, they gave me all three sides, so I was able to pick whatever sides I wanted to use. All right, so this next one, you don't have the choice. We have to do find the value of x, round your answer to the nearest degree, but I'm stuck with what I have. So what I need to do is I need to take this and go, okay, what is that and what is this? This is always the hypotenuse because it's opposite the right angle. And in this case, this one's the opposite. So what trig function am I using if I'm using opposite over hypotenuse? Well, that's the sine function. Sine of my angle equals opposite over hypotenuse. So sine of x degrees is equal to the opposite over the hypotenuse. The sine of angle x is equal to 6.5 over 10. So sine inverse, again, we're looking for angle measures. So sine inverse of 6.5 over 10. We're just going to flip the input with the output, which is x degrees. So x approximately equals, and approximately equals sine inverse of 6.5 over 10 is approximately 40.5416. 40.5416. 40.5416. And it wants it to the nearest degree. So x is approximately equal to 41 degrees because I round to the nearest whole degree. All right. And that's it for that one. So the next one, yep. Here, I'll erase this just to save some room of clutter. The next one, they gave me the x, they gave me the hypotenuse, as always, and they gave me the adjacent side. So for adjacent over hypotenuse is going to be cosine. And I'll write it this way. I'll just go directly into it. So cosine of my angle is equal to the adjacent over the hypotenuse. So cosine of x degrees is equal to the adjacent 10 over the hypotenuse 27. Okay, so cosine inverse of 10 over 27 is equal to x degrees. So x approximately equals cosine inverse of 10 over 27 cosine inverse of 10 over 27. And I get about 68.2615. And it wants the nearest degree, so I'm going to say 68 degrees. It rounds down, rounds off. Okay. And that's it. And 68 for that one. Good. Now, here's a real world example. Carlos is planning to build a grain bin with a radius of 15 feet. Take a look. Here's a grain bin with 15 feet. Okay. He reads that the recommended slant of the roof is 25 degrees. You know, because of snow and weather, if too much snow builds up and it doesn't slide off, it's going to become too heavy. So you want some type of pitch. And looks like it's 25 with a one inch overhang. Okay, 1 foot overhang. It says he wants the roof to overhang the edge by 1 foot of the bin, by 1 foot. What should the length of x be? Give your answer in feet and inches. So let's take a look. Right now, we want to know the length of this right here. It says what should the length of x be? So if we know that this is 15, what color did I? Purple. Okay. What we know is if this is right here, right, these are equivalent. So that right there is 15 feet. There's also an extra 1 foot here. So this total length is 16 feet of this triangle. So let me separate it. I'm going to draw this out. I'm going to draw this out. And that triangle, I'm just going to pull it out because I think it's a little bit easier seeing it over here. This is 16 feet. This is 25 degrees. This is a right angle. And we don't know what x is. So what I do know, though, is that I can use that 25. All right, I'm going to solve for x. Now, we haven't done a problem like this. We wrote a ratio. We did inverse, where we found an angle, but we have not yet found a side length using sine, cosine, or tangent. But we can do that. So I'm going to set this up as, I'm going to say the sine, oh, not sine, hold on. It looks like it's the adjacent angle. It's the adjacent, right? So adjacent and the hypotenuse. The opposite is way over here. So we're not doing the opposite. So the adjacent, we're gonna work with cosine because the cosine of my angle is equal to the adjacent over the hypotenuse. So the cosine, now I'm not doing inverse because I actually have an angle. I don't want to try to find an angle, so I'm doing the cosine of 25 degrees is equal to the adjacent side 16 over x, which is the hypotenuse. So let me move this work over here. And what I need to do is multiply both sides by x. So I have x times cosine of 25. Remember in the last lesson I told you, you'll get pretty good at this. If you want to just flip them, you can. You have x in the numerator and you have cosine of 25 in the denominator. So your answer is x equals 16 over cosine of 25. But if you're not that good at it yet and you want to do it step by step, you can, which is what I'm doing right now. It's the cosine of 25 degrees. All right, and you're going to get rid of that. And so x is equal to 16 over the cosine of 25. So we just solved for the side length as an exact value. What we haven't done yet is we haven't found the approximate value of it. All right, so x approximately equals 16 over cosine of 25. Which appears to be 17.654. 17.654. Okay, it says give your answer in feet and inches. Okay, well, x is approximately then 17 feet and blank inches. Right? It's 17 feet. It's 0.654 of a foot. So I know it's 17 right away, but 0.654. So let's take 17 away from this number, okay? So let's do that again. 16 divided by cosine. I just want to leave my work there so you can see it. So cosine of 25. And let's from there take away 17. So that number right there is what I need to work with to find out how many inches. Okay, now 0.6540467 feet times 12 inches gets me, it gets me 7.8485. And you know what I'm going to do just for the heck of it right now? Whoops. I'm going to screenshot that work so that you have it. I'll throw it in here. Whoops. Yeah, that will be good. So you'll have this. I'll be able to throw this in here so you'll be able to see the work that we did. Oh, I don't know where I'm going to put it. I'm going to try to fit it. It's not going to be the greatest over here, but there we go. That works. You know what? I'll put it over here. And that just goes to, I don't like it there. Okay. And so how many inches is that? It looks like 65% of a foot is 7.84 inches. So what we can do is we can round 7.848 to 7.85 inches. That's about it. 17 feet and, and about 8 inches. It doesn't ask me how to round, so I'm going to round to the best of my ability. Okay? All right. This next problem, use what you know about trigonometric ratios and other identities to show that each equation is an identity. An identity means that they're the same thing. That instead of using one, I could use the other. In this case, it says the tangent of x and the sine of x over the cosine of x. They're saying that these are equivalent. And you go, well, what? How are they equivalent? Well, let's think. What is tangent? Tangent is the opposite over the adjacent. And here, what we have is we have sine, which is opposite over hypotenuse. And then we have cosine, which is the adjacent over the hypotenuse. And you go, whoa, well, this is kind of confusing. But let's take a look. Let's actually do the algebra out for this. Remember when you take a fraction divided by a fraction? This is really messy. We're going to take this fraction, change it to multiplication from division, and then flip this because we want its reciprocal, right? Keep, change, flip, or I don't really know what you've memorized in the past, but we'll keep it, we'll change it, and we'll flip it. So we'll do over A equals O over H times, instead of division, and this is going to flip. So it's going to be H over A. You know what? Let me do it in the same colors. So we're going to get O over 8 over A. We'll get over A. Equals. It's going to be O over H times H over A. And we're almost there because what happens? What is H divided by H? Goes away, right? So my final result is O over A equals O over A, which checks out. So what we did was we just proved that tangent truly does equal sine over cosine, which is really cool. This other identity, here we have the sine and the cosine and the tangent. Well, let's write them all out. So the sine is opposite over hypotenuse. the cosine is the adjacent over hypotenuse, and the tangent times tangent is opposite over adjacent. All right. And then we go, oh, look at the A's. The A's will go away. So O over H equals O over H. And that checks out. And the last one, we have cosine, which is opposite over adjacent. And that is equal to the opposite over hypotenuse, which is sine, and then tangent is opposite over adjacent. So when we, again, keep change flip, so we'll keep the numerator the way it is. So the numerator is O over H, and we'll multiply it by the reciprocal of O over A, which is A over O. And bada bing, bada boom, these go away. So we get O over, I'm sorry, hold on. Cosine, is opposite over hypotenuse. Oh my God, this is all wrong. Cosine is the adjacent over the hypotenuse. The sine is opposite over hypotenuse. The tangent is opposite over adjacent. So this side is fine. This side I messed up. A over H. Okay, let me erase that. And so now A over H equals A over H. Sorry about that, those mistakes there. Tired making this video. All right, so that's just showing you why those identities work. Remember, that also relates to why sine and cosine are cofunctions, because sine of A is opposite over hypotenuse, but the cosine of B is the adjacent over the hypotenuse, which is the same leg over the hypotenuse, which is why those work out the way they do. All right, couple more, and then we'll be done. We have one slide left, okay? So it says, error analysis. A student states that sine of A is greater than sine of X because the lengths of the sides of A, B, and C are greater than the lengths of the sides of triangle XYZ. Is a student correct? Explain. So the sine of A is greater than the sine of X. And that's because the lengths of the sides of A, B, C are greater than the lengths of the sides of XYZ. Here's the thing. The answer is no. The answer is a big no. Here's what it's saying. It's saying that the sine of A is greater than the sine of X because opposite over hypotenuse is going to be greater than opposite over hypotenuse. It can't be. The way ratios work, it doesn't matter. The sine of 35, no matter how you look at it, the sine of 35 is always, the sine of 35 degrees is always 0.57. No matter what, it's always 0.57. So it doesn't matter if this is 0.57 over 1 or if it's 5.7 over 10, right? Because 0.57 over 1 is 0.57. 5.7 over 10 is also 0.57. So it could be that. It's just magnified. So the answer is no. Ratios are always consistent. Ratios of trig functions are equivalent. Equivalent. I just want to EQUIL. Oh, wait, equivalent. Just want to make sure I spell it right. EQUIV. Yep, I knew I was wrong. UIVALENT Okay, so no, the ratios of trigonometric functions are equivalent regardless of a triangle size. Of a right triangle's size. That's what allows us to actually use trig. All right, so this next one, find the values of w and then of x. Round the lengths to the nearest tenth and angle measures to the nearest degree. Okay, so what I'm going to do here is, now this is a 30, 60, 90. So you might go right away, oh, if that's 6, that's the hypotenuse. Opposite the 30 has to be half of that, which will be 3. That's fine, but I'm going to use trig to show you. So the sine of an angle is equal to the sine of 30 degrees is equal to the opposite w over the hypotenuse. I'm going to multiply both sides by 6. So w equals, or 6 times sine of 30 degrees equals w. Okay, and let's see. Ooh, I don't want that. I don't want that either. Okay. So 6 sine of 30 is going to be 3. So w equals 3. And so we have 3 here. And now I need to find x. So the so for x, to save room, I'm just going to talk it out. I'm not going to write it all down in terms of like what I'm doing. So I'm going to do cosine of x, which is adjacent over hypotenuse. Okay, so the cosine of x, the cosine of angle x, is equal to the adjacent side over the hypotenuse. So cosine inverse of 3 over 4 is equal to x degrees. So x, let's see, cosine inverse of 3 over 4 is 41.4096. So x approximately equals nearest degree, which is 41 degrees. Approximately equals 41 degrees. All right, and w is equal to 3. Not too bad. All right, w now for this one. So I'm going to, whatever w is, it's the same as this angle over here, so I can use it right over there. So I'm going to do the, where did I leave off? Purple. Okay, so the sine of w degrees is equal to 6 over 10, which is the opposite over the hypotenuse. So sine inverse of 6 over 10 equals w. So w approximately equals sine inverse of, sine inverse of 6 divided by 10, which is about 36.869897 degrees. So I'm going to say w approximately, you know what, I'm going to get rid of some of those. Let's get rid of those. No, because they all round up, so it's really hard to end it. I'm going to say 699 degrees. So this equals about 37 degrees. That's it, rounded. Now that's W. Now I need to solve for X. Here's what I want you to do. I want you to be careful about using an intermediate value. So let's just leave that answer here in our, over here, this answer that's on my calculator. Let's leave it just the way it is because I'm going to reuse that if possible. So I'm going to do the next one, which is right here. This is about 37 degrees. Okay, so I'm going to do, for this one, it looks like it's the, what? The adjacent over the hypotenuse. So I'm using cosine. And the cosine of 37 degrees is equal to 6 over x. Okay, and the people that are really good at this will just flip them, right? X with cosine of 37, so you do 6 over the cosine of 37. But I'll do the algebra out for those of you who like to do the algebra. Multiply both sides by x. We get x cosine of 37 degrees equals 6. And then we're going to divide both sides by the cosine of 37. Boom. And we get x equals 6 over the cosine of 37. And we are going to approximate x. Now here's the thing. Let's take a look. 6 divided by cosine of 37 is that. But look at what I really got beforehand. I actually got the angle. I didn't get 37. I get an approximate value. So let me try to type in some of that approximate value. 36.8698, 8698, 976, 976, 458. Look how close I get to 7.5. So this isn't going to necessarily, when I round lengths to nearest tenth and the angle to nearest degree, notice that it's so close it rounds to 7.5. It's not exact. I mean, it could be exactly 7.5. We notice it's not off too much, but we want to be careful when we're using what's called an intermediate value, which was that 37, or well, the 36.86. So I'm going to say it's about 7.5. Regardless, it didn't change my outcome, but sometimes it does. So we want to just use, as close to a value as we can. Remember, this thing right here is called an intermediate value. Okay, this last one, ooh, let's try to move this a little bit over here so it's not in the way. All right, this last one, we're going to solve for W first. Let's see. What do I have here? I have an isosceles triangle. Yep, I'm seeing it right now. And I also have 42 and W and 102. All right, so here's the deal. Let's start with the sine of 42 degrees, which is equal to W over 102. And this one's nice. I can just multiply both sides by 102 because it's in a numerator. So W equals 102 times sine of 42 degrees. And so W approximately equals, what do we got? 102 sine of 42. So W equals about 68.25132. So W approximately equals, and we're looking for side lengths to the nearest tenth. So 68.3. That's our nearest length rounded. Okay, and the next thing we want to do is solve for x. All right, so this is interesting. What I can do is I can actually solve for this value right here and then just double it, because what we have is we have a isosceles triangle, making this exactly in the middle here. It looks, yeah, it's going to be half because of its perpendicularism that's happening right there. So I can definitely, again, you're using 102. If you did both triangles separately, you have 102 as your hypotenuse in both triangles, and then you have W as the side, 68.3. So here, to solve for this one, you would be using, actually, you don't even need the 68.3 anymore, using this and 102 and this and 102, both with 42-degree angles. They're both going to be the same. So I can solve for this piece right here. I'll call this the unknown. I'll call this one y, and then I'll just double y to get x. So I'm going to do the cosine of 42. The cosine of 42 degrees is equal to y over 102. So just multiply both sides by 102. Again, it's the adjacent to 42, the adjacent over the hypotenuse. So multiply both sides by 102. So we get 102 cosine of 42 degrees is equal to y. And so y approximately equals 75.8.8007. So y approximately equals, we're rounding, this is a side length to 75.8, okay? But we're not interested in finding y, we're interested in finding x. So x equals 2 y's. So x equals 2 times 75.8. So x approximately equals, so I'm just going to multiply this number by, so 102 cosine of 42 times 2. And I get 151.6. 151.6 approximately, rounded to the nearest tenth. All right. 151.6. And that's it. Okay, so we'll do the rest of the notes in class, and good luck on your IXLs.